Today we will do electric field of an electric dipole for points on the axis. So let us start. Let us say let the point P, because so here we could see in this diagram we have electric dipole here. Because of this charge plus Q and minus Q here together, they will form a dipole, and point here, this point here is the center. Let us say point O. Point O is the center of the dipole. Now we want to find the electric field at point P, which is on the axis of the dipole itself. So we will find the electric field at point P because of this dipole here. Now we have seen that the length of this dipole is 2a. O is the center of the dipole, and then we want to find the electric field at point P. So let us write, let the point P be at a distance. Let the point P be at a distance, let us say r, from the center of the dipole on the side of the charge Q or plus Q, as we have seen here on the charge plus Q here. So we will find the electric field at point P, which is at the distance r from the center of the dipole there. Okay, as shown in figure 1. In figure 1 there. So then we can write the electric field due to a point charge minus Q will be EQ, which is equal to minus Q by 4 pi epsilon naught, then R plus A here, the distance square, and the unit vector P. So R plus A, the distance is R plus this A, so R plus A. Name this as equation number 1, where we can write here where P cap is the unit vector, along the dipole axis from minus Q to plus Q. Also we know that the electric field, because of the point charge plus Q, is given by E plus Q. So Q will be 4 pi epsilon naught R minus A now square to the unit vector P. Name this as equation number 2. Now we will add so that we will get the total electric field at point P. So that the total electric field at P is given by E, let us say EA representing the axis, so EA, which is equal to E because of the charge plus Q plus E because of the charge minus Q, which is equal to, now if I substitute, or we can write here, or EA, which is equal to, we substitute the value of E plus Q and E minus Q from equation 1 and 2, we have Q by 4 pi epsilon naught R minus A whole thing square, and then P cap minus Q by 4 pi epsilon naught R plus A whole thing square to the P cap. Okay, so now our EA will be equal to, we take common the value of Q by 4 pi epsilon naught, then here will remain 1 by R minus A whole thing square, and minus here will remain 1 by R plus A whole thing square, then the unit vector P. Now, or we can write EA here it will be equal to Q by 4 pi epsilon naught. Then here we calculate this part which is inside the bracket, so it will be R plus A whole thing square minus R minus A whole thing square divided by R minus A whole thing square and R plus A whole thing square. Name this and then this unit vector P. So now let us write that side. Or EA, we can write here EA will be equal to Q by 4 pi epsilon naught. Then here it will be like A plus B whole thing square, so it will be A square plus 2AB plus B square minus, now the next one, A square minus 2AB then 2AR plus B square. B square is A, so divided by it is R minus A whole thing square, and R into R plus A whole thing square, it will be R square formula minus A square whole thing square, then the unit vector P. So here, or we can write EA be equal to Q by 4 pi epsilon naught, then R square plus 2AR plus A square minus R square plus 2AR minus A square divided by R square minus A square whole thing square, unit vector P. R square and minus R square cancel, A square and plus A square and minus A square cancel, so we have, or EA will be equal to Q by 4 pi epsilon naught, then here it will be 4AR by R square minus A square whole thing square, then P to the unit vector. Now instead of writing 4AR here, we will write it in another form, so EA which is equal to we can write 2 here, so then it will be Q into 2A. So okay, we will solve first for R. We will assume that R is much greater than A, so here we assume that, or let me write one more step, EA, it will be equal to 4QAR divided by 4 pi epsilon naught R square minus A square whole thing square P cap. Now for R is much greater than A. For R is much greater than A, R square minus A square will be approximately equal to R square. So then it will be, then we have EA will be equal to 4QAR divided by 4 pi epsilon naught R. This A will be, this will be R square only, so R square with this square it will be R to the power 4. Now cancel this R and this 4, it will be R to the power 3 left. Okay, so it will be, or we can write EA which is equal to 4QA divided by 4 pi epsilon naught R to the power 3 and unit vector P there. Unit vector P, I forget to write. So now we will arrange this for QA, or EA will be equal to, we can write 2 here, Q into 2A divided by 4 pi epsilon naught R to the power 3P. Now we know that the electric dipole moment P is equal to Q into 2A with the unit vector P. So instead of all this value, we will write the electric dipole moment P. So or EA will be equal to 2 into P vector divided by 4 pi epsilon naught r to the power 3. Now we name this as equation number 3. Here we have to remember one thing, that r is much greater than A. That's all. So equation 3 is the required equation, it gives the electric field the electric fields of an electric dipole on a point P on the axis of the dipole, So with this we complete the topic today. Thank you.